Hello everyone, we are group 4 and for our final project we will go over the impact of color on a structure's temperature. In this presentation we will go over the background of our experiment, the details, and the results. There are several reasons why cool colors are popular in warm regions. It could be for practical, historical, or for aesthetic reasons. However, the main purpose of the use of cool colors is to reflect light. This is most beneficial in places with hot climates and in structures without air conditioning. Some of the benefits of using cool colors include energy efficiency. Since less heat enters a building, air conditioners run less frequently, which then lowers electricity use. Another benefit of using cool color is reduced air pollution. And lastly, longer lifespan. Since high heat accelerates roof degradation, white roofs or structures experience less thermal stress and often last longer than dark roofs because they stay cooler. And that image on the top left corner, that is a single family home. This home is probably located in a region that snows frequently, and they are using black colored roofs to help melt snow faster. And the one on the top right corner, this is in Santorini Island, Greece. This one is located in the Mediterranean, and due to the geographical location, white color is typically used to paint their walls, and this is to reflect light. And the bottom left corner, this one is located in Kotor, Montenegro. These tiles are made of terracotta, and this is the most abundant material in that region. And for this experiment, we wanted to confirm if the color of the structure truly affects the indoor temperature, which guided us to our research question: can the color of the structure affect indoor temperature and energy efficiency?
The materials needed for the experiment were 3 cars, each having a different exterior color. So one that was a lighter colored one medium colored car, and a darker colored car, so a total of 3. We also needed about 3 or 4 thermometers to measure the temperature both inside the cars and outside, a log to record the temperatures, a timer or stopwatch, and a place to park the cars that allowed for direct sunlight exposure with minimal shaded areas. For the actual procedure and how we collected data, we first made sure that each car was parked in an area with full sunlight. The second was that we recorded the ambient temperature outside. The third was to measure the initial temperature of the car using a thermometer without leaving the door open for too long. Then to leave the thermometer in part of a car that is not in sunlight. Then we would leave the cars with its windows and doors closed and make sure the air conditioner had been turned off. The 6th step was to take the final temperature of the car after 1 hour, and then we would move on to calculating the change in temperature by subtracting the starting temperature from the final temperature. And the last step in our procedural design was to analyze the data to determine how color impacts a structure's internal temperature.
Our hypothesis is that a dark-colored car would have a faster increase in temperature change after an hour in the sun, compared to a light-colored car. Our hypothesis was proven untrue in this experiment.
For our project, we looked at how car color changed the temperature inside when it set in the sun. We tested a white car, a gray car, and a dark purple car. The white car got the hottest, about 39 degrees hotter. The gray car got a little hotter, about 7 degrees. And the dark purple car barely changed, only 1 degree. This shows that light colors get hotter faster than dark colors. The weather was different on the days we tested, so it would be better to test all cars at the same time. Overall, we learned how sunlight, color, and heat affect cars in real life. Thank you for watching our project.